In this chapter, we will be reviewing and introducing some ideas in statistics. In this lesson, we're going to look at confidence intervals.
Okay, everybody. We're going to take a look at confidence intervals in this particular lesson. So we've been doing a bunch of work with statistics and looking at populations, and we're looking at distribution and whatnot. Then we're taking a look at this thing called confidence intervals. And you do hear these referred to quite frequently, but you may have just kind of disregarded the information when you hear it. It becomes particularly important around election times. You'll hear about polls that are done, and then they'll give you this poll is accurate 95 to within like 5%, 19 times out of 20. And what they're trying to do here is give you some sort of an idea of how much you can trust the information that we're given. So we're going to talk about confidence intervals just a little bit here. So the example we start off with here, it says Mr. Clausen wants to determine the average height of all the students for the entire school. However, measuring every single student would be very difficult and time-consuming. He instead decides to use his class of 30 students as a sample of the entire Ross Shepherd population. So the heights in centimeters of his students are as follows, and so they're given right here. And we're supposed to use the calculator to find the mean and the standard deviation. So now, I'm not going to spend the time to enter that all in. I've already done that. But I do want to walk through how you would do this again on your calculator, for no other reason, just to review it. So normally what you would do here is you would press Stat, Edit, enter on Edit, and then you would enter all the data in, and I've already done that. So now I'm going to quit out of there. To get the mean and the standard deviation, it's Stat. Now that the data is all in there, we'll go over to Calc. And remember, it's this one variable statistic thing. I've got it in list 1, but I don't have any frequency in list 2, so I'm going to get rid of that. And just hit enter on Calculate. And then here we go. And so the mean is 161.9, and my standard deviation is, let's say, 10.1. Okay, so I'm grabbing the mean from the top here, and then remember, this is my standard deviation right here. Now, let's keep going here, just looking through this. So what this tells us is the mean for this specific sample is 161.9. In order to expand on this study to include the whole school, we need to account for a certain margin of error, which is basically to say that my particular class, or Mr. Clausen's particular class maybe, is not necessarily representative of the whole. It might be too short or too tall on average here. So we're going to determine the margin of error. And let's say that Mr. Clausen determines that the margin of error is 19.8 centimeters. And that when I do that calculation, that gives me a 95% level of confidence, okay? So this tells us that the actual mean for the heights of the students at the school, okay, the actual mean is within 19.8 centimeters on either side of Mr. Clausen's sample mean of 161.9. So this allows us to get a 95% confidence interval. In other words, what I'm going to do is I'm going to start off with here is I'm going to take this information, what I think the mean is, and I'm going to subtract 19.8 from that. Okay? So let's go to our calculator here. Whoops, sorry. And I've got 161.9, and I'm going to subtract 19.8 from that. So the low bound that we could get here is 142.1. If we take 161.9, oops, 0.9, and we add 19.8 to that, we get 181.7. Okay? So we took the mean, we had this margin of error at 19.8 centimeters. If I subtract 19.8 from the mean, I get 142.1. If I add 19.8 to the mean, I get 181.7. So now what we're going to say is we are 95% sure, okay, that the actual mean for the students in the school is somewhere between those two values. That's what we mean by confidence interval. My data supports a 95% confidence statement that it's going to be somewhere between 142.1 and 181.7. Okay. Whoops, come on. Okay, there we go. So, after sampling the weights of golf balls at Golf World, okay, Golf Ball Factory, it was determined that golf balls weigh 46.7 grams plus or minus 0.5 grams. And that these results are accurate 95% of the time. So now, again, this is this confidence interval that I'm giving you here. So the mean that we're talking about here is this 46.7. Okay, let's connect that. So this is the mean that was calculated. And then the margin of error is this 0.5 grams here. It's this plus or minus part right here, plus or minus 0.5 grams here. So that's the possible difference between above or below the sample mean and the population mean. So the confidence level of 95% here, this is the likelihood that the true population mean lies in that interval. Okay, in other words, if you did this same experiment over and over and over again, 95% of the time, the average golf ball mass will be somewhere in that interval that we've just calculated there, right? So sometimes this percentage can be represented as a fraction, and this is where you heard me say this a little bit earlier, this 19 times out of 20. When you hear that stated on like a political poll, that's what they're meaning. They're 95% sure that the result that they get is in this particular, is around this particular little area there. Other confidence intervals that you'll get will be 90%, even 99%, but 95 is quite common. So how do you get that interval here? Well, you start with your sample mean and you've got plus or minus the margin of error. So what you're going to do is you're going to take that mean, subtract the margin of error to get the low bound, add the margin of error to get the high bound. So in this particular case here, our low bound was 46.2 grams, our high bound is 47.2 grams. So what do we say? We say that we are 95% confident that the actual mean weight of a golf ball, okay, produced by this company here is going to be somewhere between 46.2 and 47.2 grams. So, is it likely that the true population mean of a golf ball is 45.9 grams? Well, look at your confidence interval. Well, this is lower than your 95% confidence interval, so the answer to that is no. No, it's not very likely that it's going to be 45.9 grams. Is it possible that the true population mean weight of a golf ball is 45.9 grams? Yes, absolutely it is, but not likely. Okay? And so I hope you understand that. Is it likely to be that way? No, because it's outside our 95% confidence interval. Is it possible? Yes. But if there's like a 5% chance, well, actually, because it's symmetric here, you gotta think of it like this even. We've got 95% here at the center. That doesn't mean 5% here and 5% here. It means 2.5% here and 2.5% here. So no, it's even less likely than 5% that it's down here below the confidence interval. So that's how you'd have to interpret that. Okay, so let's do some examples here. So after measuring a sample of chocolate bars, Choco Press Chocolate Bar Manufacturing Company has found that the mean mass of its chocolate bars to be 56 grams plus or minus 2 grams, 19 times out of 20. So 19 times out of 20, we just saw that. That's our 95% confidence interval. So determine the confidence level here. Okay, well, I just said it. It's 95% confidence level. We just did that. Okay, that's our 19 out of 20. The margin of error was 2 grams. Okay, plus or minus the 2 grams there. So determine the confidence interval for the mean mass here. Well, okay, 56 grams minus 2 grams will be 54 grams. 56 grams plus 2 grams is 58 grams. So we are 95% sure that the actual mass of this chocolate bar will be between 54 and 58 grams. Is it possible that the true mean mass of the chocolate bars produced is 60 grams? Yes, it is. Okay. Now it says why or why not. Well, it is Okay, because these are all probabilities. Are all probabilities, and there is still a possibility it could be 60. Okay, but, and this is a huge but it is very unlikely. Whoops. Spelling that wrong. See, teach math. Okay. But is very, very unlikely to be outside of that particular range there. Okay, so this question says the confidence interval for the true mean of the Math 30-2 diploma is 80.4% to 83.6% at a confidence level of 90%. So a confidence level of 90% could also be described as what? Well, okay, this one is actually pretty straightforward. If it's 90%, probably the easiest way to give that is 9 times out of 10. I mean, that's the nicest way, smallest way to give me those numbers there. Determine the original sample mean. Okay, well, this is our low bound. This is our high bound. Our mean is going to be exactly halfway in between there. So let's figure that out. So let's go 80.4 plus 83.6, divide that by 2. So over here, 80.4 on my calculator plus 83.6 divide by 2, and I'm getting 82. So it's going to be 82%. Okay? Determine the margin of error. Well, this is going to be our plus or minus what? So 82 is in the middle here. Now compare that to the low bound, 80.4 and 83.6. You can either subtract 80.4 from that or subtract 82 from 83.6 to see that this was plus or minus 1.6%. Okay? So there's my margin of error. Is it likely that the true mean of the 30-dash diploma is 79%? Why or why not? In this case, this is a very different question than the previous one up here. This question up here was, is it possible? Yes. Yes, it is possible. However, here, is it likely? And the answer is no. Because the value of the mean, okay, is 95% of the time going to be between, what do we have here, 80.4% and 83.6%, okay? The probability it is outside this is low, meaning it's unlikely. So because 79 is outside of that particular range there, it is very unlikely to occur. Okay, here we go. 5 people are running for class president. After polling a sample of the student population, the Students' Union found that 39% of the student body said that they would vote for Alexa. These results are accurate within 3%, 19 times out of 20. Okay, so there it is again. There's my confidence level right there. So when it says determine the confidence level, 19 out of 20, okay, there's my 95% confidence interval. Now, state the margin of error. The question told me that. It's accurate to within 3%. So 3% is my margin of error. So in other words, what we've got here is we have this mark of 39% plus or minus 3% is what we're saying. So what's the confidence interval? Well, 39 minus 3%, so 36%, to 39 plus 3% to 42%. So we are 95% sure that if you did this poll over and over and over again, okay, you would get your results to be somewhere between 36 and 42. Okay? Now, the Students' Union poll results also show that 36% of the student body would vote for Reed, accurate to within 2%, 19 times out of 20. and 28% of the student body would vote for Daniel, within 4%, 19 times out of 20. So we're going to determine the confidence level intervals, okay, for Alexa, which I believe we just did. So that was, actually, I think probably what they meant was here was Reed. Let's say Reed, because we've already done Alexa. So for Reed, the confidence interval, in this case, they're all 95%. The confidence interval here is going to be 36 plus or minus 2%. So this is going to be 34% to 38%. And for Daniel, it was 28% plus or minus 4%. So the low end there we're going to subtract, so 24% to 32%. Okay? So those are our intervals for each of these students here. Now, are we able to make a conclusion on who will win the election? Well, let's just take a quick look at this. Okay. Does anybody here have an absolutely clear majority? Well, not really. Not really. I mean, let's take a quick look at this. We've got 36 to 42%, 34% to 38%. Well, there's a little bit of overlap there. Okay. Now, it seems fairly clear that Daniel won't win. But there is some overlap here in the expectation between these two. So are we able to make a conclusion? Well, no. The intervals, okay, for Alexa and Reed overlap. Okay. So a clear judgment isn't possible. We just don't know for sure. Now, are we able to make a conclusion on who will not win the election? Well, yes, Daniel. Okay, his interval is clearly below the others. Okay, so it is highly unlikely that he would get the kind of support that would be required to take out the other two. Okay, so we are 95% sure that he is going to be below the others significantly. Okay, we might even write that down. We are 95% sure he will be below the others. Okay, and that's going to be significant. Okay, so before we leave this here, just one more comment here on sample size and margin of error. Okay, if you wanted to be 100% confident about the results, okay, then you need to talk to everybody. You need to poll everybody. Okay, so let's say we'll go back to Mr. Clausen's class here. If he wanted to be 100% sure that his results were accurate, then he'd need to talk to every single student at the school, Ross Shepherd, and there are approximately 2,000 students there. Now, let's say that that's not necessarily the goal, to be 100% accurate. Just notice this, that if in the original one he surveyed 30 students, okay? Now, if he was to measure the heights of 300 students, then your confidence would go up in his results, because he's contacted more and more students. The more data you've got, the more trustworthy your conclusions are going to be, okay? Because you've talked to more and more students. That's still not 100%, unless you've talked to 100% of the people. But compare that to this. If you measured the heights of only 3 students, your confidence would be quite low in those results. Okay, there's just way too much room for sampling error. Okay, maybe, I mean, if he went to the basketball team inadvertently and talked to them, well, then those results are going to be way out of line with the rest of the group, okay? So for a fixed margin of error, as the sample size increases, the confidence level also increases, okay? The more people you talk to, okay, the greater your confidence. You're going to go from like 95% to 99% and 99.99% and so on, okay? Until you get up to 100% after you've talked to everybody. Okay, so let's take a look at this question here. A company that produces lacrosse balls, okay, anyway, sorry, I said that wrong. A company produces lacrosse balls. League regulations state that the weights of a lacrosse ball must in a game must be between 4.75 ounces and 5.25 ounces. Quality control testing is done on the production machine and calculates the balls have a mean mass of 5 ounces with a margin of error of 0.15 ounces at a confidence level of 95%. So let's state the confidence interval for the quality control testing there. So what we've got there is we've got 5 ounces. Basically, it looks like this, right? We've got 5.00 ounces plus or minus 0.15 ounces, okay? So what we're going to do is we're going to add and subtract to get our interval here. We're going to add and subtract. So if you subtract 0.15 ounces, we're going to get 4.85 ounces to 5.15 ounces. And we are 95% sure, okay, that the ball is going to fall within that interval right there, which is great because we are allowed 4.75 to 5.25 ounces. So the company's in a good position here. They're pretty consistently producing balls that fall within the required zone there and well within the required zone. So the quality control testing produces more specific results than required by the league. To save time and money on quality control testing, the company could do what to its sample size and do what to its level of confidence? Well, to save money and time here, they're in a comfortable position here. They could decrease their sample size. They're already doing quite well, so they could probably stand to decrease how picky they are. Now, what that does here is that decreases their level of confidence. Okay, it will automatically decrease their level of confidence, but they're at this point right here, they're already 95% sure they're well within the margin of error for the league. So they can afford to get away with doing that.